For situation A is looking at 3 teams. Sorry, a little delayed there. Okay. Looking at 3 teams, right, Jaguars, Wolves, and Lions, and they played 5 games. So, using what we know, suppose you want to join one of the 3 basketball teams. You want to join the one that is doing the best so far. If you rank each team by their mean scores, which team would you join? Yep. The Jaguars. Good. Okay. They had the highest average. Awesome. Okay, instead of using the mean scores, you want to use the median. Which team would you choose? Andrew? The Wolves. Good. Okay. Pretend you are a coach of the Lions and you are being interviewed about your team for the local newspaper. Would it be better for you to report the mean score or the median? Brian? Good. The mean, because it is higher. In fact, the mean was 68.2 as opposed to the median, which was 65. Any questions 1 through 3? All right. Then you get into comparing number of times you've been to the movies in the past year. Okay, you have John, Mary, Brian, Kelly, and then the months. By comparing the modes, which person went to the movie the least? Sam? Mary had a mode of 1. It's okay. Mary was definitely the least, okay, out of the 2. How about by comparing medians? Which person went to the movies the most? If we compare the medians. Charlotte? Good. All had the same. Which was what? 2. Good. Awesome. Okay, all had the same. So now you want to rank the friends in order of most movies seen to the least. Who had the most? Who went to the movies the most? Brian? Good. Yep. Good. Okay. So John and Brian had the same, then Kelly, then Mary. Good. Which month, by comparing the means of movies seen in each month, was the most popular movie watching month? July. Good. Now, if we look at the medians, which month was the least popular? Lindsay. January. Good. January. Awesome. Okay. Now, this last question might have confused some. Okay. What is the mean of the medians for each month? So you got to take the median of each month, each of the 12 months, then take the average. What did we get? Brian? Okay, if you round to the tenths, did we get 2.08? Yep. Okay, that is correct. 2.08. So, if we take the medians of each, we had 1, 2.5, 1.5, 1.5, 1.5, 3, 3.5, 2.5, 2. If we take the medians of them all, then take the average. So add those all up and divide by 12, we would get the 2.08. Okay? Any questions on this? Okay? Any questions on the 4.1 practice that you guys had? Charlotte? 20? Yep. Yep. Okay. So, for number 20, in a certain course, the student's final mark is computing using the following. So, quizzes are worth 10%. Tests are worth 40. And the exam is worth 50. Okay? That's what makes up the student's final mark. Okay. Now, Alfredo's final mark was a 70. Do we know what it was? That's what we're finding out the final mark. Never mind. I'm thinking of another question. Okay. So for quizzes, he earned an 81. For a test, he earned 75. And then for the exam was a 70. So to find the final mark, we have to take 81 times 10%, 75 times 40%, then we have 70 times 50%, and then we add those guys all up, okay? So 81 times 10% is the 8.1, 75 times the 40% was what? Anybody have it written?
Oh, wait, that's 30.
30, good. And then 70 times the 50% was what? 35. When you add those all up, you get 73.1% as the final mark. Okay? Makes sense? Any other questions that you guys came across? Yeah, Liz. Yep. Number 11 is using our calculator. Okay? So it's using our stat edit. You could do it this way, or you could do it by hand, okay? So in your calculator, just a little recap, you go to stat edit. If you have anything in L1, okay, you should see L1, L2, L3. If you start at L2, you deleted your list, okay? So to clear your list, highlight L1, clear, and then enter. Then you want to enter in all that information. Be careful you don't, one number can throw you off completely, okay? So 64.5, 63, 61, 62, 47. And you guys check too, make sure I'm not missing anything. Oops. Ah. Okay, 60 and then 53, 38.5, 48, 55, 65, 55. Okay, once you have all that data in, and there should be 22 entries, right? I think 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay, so from here you go to stat, 1 over to calc, 1 var statistics, enter. Your mean was 55.8, okay, 82, but it said, didn't say, nearest 10th. So 55.8, your minimum was 38.5, your median was 58, your max was 65. To find the range, your max minus your min, okay? How do we find the mode? Well, here you could go stat, number 2, second, number 1, where it says done. If you go back to your list, they're all in order. So if you scroll, or just looking at the numbers, 58 was the mode, okay? There's no calculator tool for that, so you have to put the numbers in order to find that, okay? Does it make sense? Right? Any other questions on 4.1? All right, so have your notes out. Turn to page 8. The 4.2 practice. Notes, sorry, 4.2. All right. So again, there is a lot of information as we go through this, but it's going to seem very similar, all right? No matter what, anytime we're talking about any statistics whatsoever, we're looking in your white packet of your notes. This is the 4.2 notes, okay? We're looking at visualizing the data, okay? So we always start with, and some of you probably have seen this before, is a normal curve, okay? A normal curve is a smooth curve and symmetric. So this is what a normal curve looks like, the picture in the middle of your page, okay? So where it's a normal curve, you have these tails on either end, okay, and a line in the middle. That line in the middle, okay, represents the mean and median if it is a normal curve, okay? So typically that middle spot here, if it's a normal curve, will be your mean or median. But when we label these curves, it's only going to be the mean, okay? So the mean and median would be approximately in the middle, and the two sides would be symmetrical, okay? And there's tails on either side where the data starts to flatten out, okay? Later on, as we go through this lesson, you're going to see when curves are not normal, okay? That's where we're looking at a whole bunch of different things. All right, so one more measure of dispersion, which we talked about with the range, is now called the standard deviation, okay? And in our calculator, we're looking for that SX, which talks about the spread, okay? So the standard deviation is the amount of variability. So these are some key words to use when you are describing standard deviation. The amount of variability, the amount of spread. Definition is the difference from the mean. Okay, it's the average distance from the mean if we want to look at it that way. So I want you to think of, and this will be asked on the next page, think of your test scores as a whole. Okay, say the average was 88, and I have a standard deviation of 3. That means there's not a lot of variability, and the majority of the class was within that range, which was close to the average of 88. If I have a standard deviation of 15, and I'm just throwing out numbers, there's no benchmark to tell if it's small or large. If I have a standard deviation of 15, that means the scores are all over the place, or there might be an outlier or two, okay? Making the data very spread out and a lot of variability. So when it comes to test scores, you want the standard deviation small, because you want it close to the average. You don't want this large spread of variability, okay? So at the bottom of that first page, you could cross out those 2 bullet points because there's no benchmark that we could pinpoint what's a small and what's a large, okay? So if it's a small spread, it's very close to the mean. The majority of data is very close to the mean. If it's a large spread, then you're going to see there's a lot of variability. It's spread out. There's no consistency. Okay? So for us, in terms of test scores, we want a very small standard deviation, because that means a lot of you, or the majority of you, are within the range of the average. Okay? There's not a lot of outliers. There's not a lot of people that did bad or a lot of people that did extremely well. You're in that average, which is where we want to be, okay? And I think for our midterm exam scores, the standard deviation was like a 3 or a 5, which is great because the average was at 89, let's just say. I don't remember the numbers off the top of my head. So there wasn't a lot of variability. The majority of the class was around the average, which is what we want, okay? So there's 2 things I'm going to show you today in terms of the normal curve. A, we're going to fill one of these things out. And B, I am going to talk to you about percentages that are standard. They do not change, okay? You will not be tested on it. However, it is a challenge for you to remember, okay? I will go through it first, and then I'll answer questions after if it doesn't make sense, okay? So, John usually scores an average of an 82 on his math test, okay, with a standard deviation of 5, okay? So, the average, and this is not John, that John back there, okay? The average is an 82, so that is our mean, okay? When we're labeling a normal curve, the mean goes right on that middle tick mark there, okay? All right, the mean goes there. Now, to figure out the range of one standard deviation above and below, okay, so one standard deviation, okay, we apply the standard deviation to the mean. So whatever we do to the right, we also have to do to the left, okay? So if we have the mean of 82, the range would be 82 plus 5 is what? 82 minus 5. 77, right? So first standard deviation is 77 to 87. So 68% of the time, John will score between 77 and 87, okay? One standard deviation, and this is some of the percentages I'm talking to you about that are always set, John's scores will fall between 77 and 87 68% of the time, okay? So his scores will fall in that range. Out of all of his data, 68% of his scores will fall in that range, okay? Yeah, John. It's something called the empirical rule, okay? So I'm going to go through it all and then explain after, okay? Answer, because as we go through it, some of your questions might be answered, okay? So, to gather second standard deviation, we keep going. So we add 5 and then subtract 5. So 87 plus 5, 77 minus 5. So second standard deviation is from 72 to 92. So within that range, John's scores will fall in that bucket from 72 to 92. 95% of his scores will fall in between there. And I'll explain after. Okay? Now, 3 standard deviations is the most we could have underneath a normal curve. Okay? 3 standard deviations is the last piece we will see. So, 92 plus 5 is what? Okay, 72 minus 5. Okay, so the third standard deviation is 67 to 97. So 99.7% of John's scores will fall between 67 and 97. Okay, now 68, 95, 99.7, those are standard. This is called the empirical rule, okay? So, if I take all of John's scores on his test, out of all these scores, 68% of all that data is going to land between 77 and 87, what he received on his test. Does that make sense? Then if I look at a broader scale, 72 to 92, 95% of all John's scores will fall within that range. Does that make sense? Okay. Then if I look at an even broader scale, which is the majority of the data, 67 to 97, 99.7% of John's scores will fall in that range. Does that make sense? But, question, can John get less than 67? And can he get over 97? Yeah, the normal curve is made up of 100%. So what's missing? What percentage are we missing? 0.3. But we have two tails. So what is the percentage of him earning less than 67? 0.15 and then over 0.15 because they're symmetrical on either side. So 0.3 makes up this little tail and this little tail. But we have to divide by 2 to find the actual percentage. So my question to you is, what is the percentage that John will score over 82? Sam? 50. How about under or less than 82? What would it be? 50. Because from 82 and above, or from this mean and above, is 50%. It splits the graph in half. Now, what percentage will John's scores be between 82 and 87? Ooh, who said it? A few of you said it. 34. Why? Good. Half of the first deviation was 68. 68 divided by 2. This small, 82 to 87, 34% of his scores will fall in there. Does that make sense? Okay. Some people get fixated on the actual percentages, but again, it's an empirical rule, so it is an estimation. When you get to higher statistics classes, if you do take them, you will actually find those exact values. Okay. This is just an estimation. Will you have to memorize this? No. But I might give you a challenge one, say, okay, fill out the normal curve, then answer these questions. Okay? And again, it's a challenge. You will not be tested on it. You will be tested on, can you fill out a normal curve? Okay? So what I want you to do quickly, number 2, just fill out that normal curve. Okay? So where do we start? Sam. Middle is 88. Okay. What is the range for one standard deviation? What would it be? Will? Good. 85 to 91. How about 2 standard deviations? Corey? Good. And 3. Campbell? Good. All right. Excellent. How many of you guys did get that? Good. So when we're doing standard deviations, you will only have 3 standard deviations above, 3 standard deviations below. There's no more after that. Okay. When we get back, we're going to look at the shape and other visual representations of graphs. All right. Head to lunch, you guys. If you turn to the next page, you're actually going to find standard deviation in our calculator. We use a calculator because finding standard deviation by hand is just, it's a long process, okay? So, some of the steps to find standard deviation are the same thing we've been doing, okay? If you go to Stat, Edit, and enter data in L1, okay? Then after that, you go back to Stat, to Calc, 1var statistics, and then we locate the mean and standard deviation, okay, which are given to us. So we are going to look at 3 different data sets first, okay? We have data set A, B, and C. Before we do anything with our calculator, looking at those 3 data sets, we will be finding the mean and standard deviation and round to the nearest hundredths. Looking at all 3 of them, which one do you think would have the largest standard deviation, the largest spread, the largest variability? John? Set A. Why? Good. The range is pretty large too. What would come next? What would be the second? Yeah. B, and then C. What do you think? Huh? it would just be 0 because it's all the same. All right, so let's check these guys out. They're quick and easy because they're only 5 numbers. So if you go to Stat Edit, right, highlight L1, clear, then enter. Enter in those 5 numbers. And then go to Stat, over to Calc, 1var statistics, enter, and then you notice our mean is 8 and our standard deviation is 7.07. Okay, SX is our standard deviation. Okay, now we're going to do the other two, so just jot those down. Stat edit, and you could type right over it if you want to instead of clearing, since they're all the same amount of numbers. Okay, that one over to Calc. And the mean is the same, however the standard deviation is 2.74. Okay, and we'll do the last one. And you notice Andrew was right, the standard deviation is 0, but it does have the same mean. So, looking at our data, the means for all of these were 8, okay? Now, 8 falls in between here, but there's so much variability in data set A that they're not that close to the average, the mean. However, looking at data set B, it's not a wide range, and they're all roughly within that average of 8. Okay, they're very close to it. And then data set C, they're all the same. So when you interpret standard deviation, you want to make sure you include anything about variability. You could include range as well, okay? And more detail the better, but it has to have some terminology of variability and or spread, okay, anytime you're interpreting it. All right, so let's give this a try. You guys are going to try 1 and 2, okay? Using your calculator, you're going to find the mean and the standard deviation. Go ahead. And round to the nearest. All right, so looking at example 1, what is our mean? What do we got? John. 75, and what is our standard deviation? 3.7 is a little too much. Just double check. What do we get? 3.5. Okay. Did you get the same mean?
Yeah.
All right. Just double check. It might have been the one below it. Okay. So right now, looking at the data given to you, okay, the mean is 75. So if we were to put these in order, you would end up seeing where the median is as well. But the standard deviation is 3.5, okay, which is on the smaller side. What can we conclude? Yeah, Brian. Good. There's a consistency there, okay? Having the standard deviation of 3.5, they're all roughly within the same ballpark. So there's not a lot of variability. On the flip side, though, when you did Nora's science grades, what was the mean? Andrew? 84. And what is the standard deviation? Corey? 15.5, which is definitely larger than this first one here. Why? Why do we think? Sam? 52 is an extreme outlier, right? Which is going to spread out the data. However, is there a lot of consistency here? There's a lot of variability, not so much consistency, okay? The variability, because we have 100, then we drop to 52, then we have an 80, we have a few 90s in there, 74 and then 80. So we can't really pinpoint where the student is. Okay, we could assume, but looking at the data, there's too much variability to kind of say what the science grade should be. All right, so normal curve, mean and median are roughly the same. Okay, it's bell-shaped and symmetric. When we really look at normal curves, before we look at that, we look at visual representations using a histogram. Okay, how many of you have seen histograms before? Okay, histograms deal with what makes them up are ranges and then frequency. Okay, ranges, yeah. So for this one or here, this one was for the above. So for that, looking at, and we kind of voiced it, okay? Looking at data set A, there's a lot of variability and the range is large, okay? That sort of thing, all right? So using a histogram, okay, you have the bars are touching together, so it's not like a bar graph where there's categories, okay? Here, there are ranges and frequency. So how many students fall into that bucket, okay? Using our histogram, we create a frequency table, okay? So for example, how many students scored between a 91 and 100? Brian? 2. How many students scored between an 81 and 90? Sam? 8. Okay. 71 and 80. 12. Good. 61 and 70. 10. Good. 51 to 60. Andrew? And then 41 to 50? 3. Good. So that's the frequency of how many students were in this histogram, right? How many in total? 40. Good. Okay. 40 will also, once you add up all the frequencies, it will tell you how many students were in this graph. So how many students got between a 61 and 90? Abigail? 30. Good. So 61 to 90 is adding up those three numbers, 8, 12, and 10, to give you 30 students earned between a 61 and 90. How about how many students got lower than a 61? Brian? 8. Okay. Then you look at these guys here. And then can we tell how many students got a 76? No, right? Why? Andrew? Perfect. It's just a range and you're not given specific information, so we cannot tell. Okay? All right. So then using the histograms, we look at the shape. Okay? This is when we evaluate the shape. Okay? When a graph is symmetric, which is this graph here, when a graph is symmetric, that's one sort of shape, then the mean is pretty much equal to the median. So if it's approximately normal graph, the mean and median would be roughly the same. And we use approximately a lot. You're going to see it here. You're going to see it on the next page. Approximately is always an estimation of what we're looking at. Okay? So one shape is symmetric. Mean and median are pretty much equal. The other two distributions, when they're not normal, is skewed right and skewed left. Please, please, please be careful when you're determining if it's skewed left or skewed right. You're looking at the tail of the data, not where the majority is. Okay, so looking at this first one, this is skewed right because the tail fans out to the right, which means the mean is greater than the median. Okay, so if it is skewed right, the mean is greater than the median. And you're looking where the tail ends up, not the majority of data. Okay? If it is skewed left, the mean is less than the median. Again, look where the tail is. Okay? That means if it's skewed right, say the majority of data is, of test scores is 88, no, let's say 80 to 85. But I had someone that got in 102. That's where it's going to make it skewed to the right. Okay? Skewed to the left would be in the opposite direction. A score of 50. Okay? So you want to pay attention to the tail, not where the majority of data is. Okay? Let's turn to the next page and tell me what's going on here. Okay. Looking at this first histogram, what do we think? Symmetric, skewed right, skewed left. Campbell? Skewed right, good. So if it is skewed right, what's the deal with the mean and median? Brian? The mean is greater than the median. And we're going to prove that a little bit later today. Okay? So using your knowledge that we just went over, okay, symmetric, skewed left, skewed right, here are three graphs. I want you to identify which one's symmetrical, which one's skewed right, which one's skewed left, and then tell me what's happening to the mean and median. Go ahead, take 2 minutes, not even, like a minute. Okay. Looking at graph A, Emily, what would we say? Careful. Yeah. Skewed right. Okay. Why would this be skewed right? Grace. Tail's going to right in terms of mean and median. Perfect. Good job. Okay. Now for B, U, what would we get here? It's symmetric. Good. Lizzie, why? For mean and median. They're equal. Good. Excellent. And then C, Bianca. Skewed left. Excellent. And Gavin, why in terms of mean and median? Perfect. Good. Okay. So you guys will see this in another distribution, visual representation. Number one being the dot plot, and then next we're going to look at the box plot, how they are different and how they could be skewed. Okay, dot plots are very similar to histograms. However, you have single data here and not ranges. Okay, and the dots in this case represent people that take that many minutes to eat breakfast. Okay, so what is the most frequent amount of time people ate breakfast? Abigail? 10 minutes, good. It's the one with the most dots. Okay, what is the range in time people eat breakfast? What is the range in time? Phoebe? 12. We have 0 to 12 or 12 minutes. Excellent. Okay, that's the ranges of how many minutes it is to eat breakfast. How many people took 8 minutes, to eat breakfast? Yeah. Yep. In this case, yes, because you're looking at a graph, you're not looking at like data. Anytime If mean and median and mode and all that is given to you in terms of range, you want a numerical value, okay? But both are acceptable because it does get confusing, like which one should we have? So, yeah. How many people took 8 minutes to eat breakfast? Two. Okay. So, looking at these 3 dot plots, don't they look very similar to histograms? The way they're kind of given to you? Yeah. Okay. The only thing that's different is you're given data points, not ranges. This would be something symmetric. You would have skewed right. This is what it looks like on a dot plot. And then skewed left. You're still looking at a tail. So if you had to draw a curve, you can, okay, to show if you're not sure. Or say if you don't even have a graph and you're looking at the data, you could tell if it's skewed right or left by looking at what 2 things? Yeah, the mean and median, which we're going to see in a few minutes. All right, turn the page. The last visual representation is our box plots. How many of you have seen these before? Okay, some of you may have seen them. You might have seen them but don't remember what they are, okay? Displaying this data separates the data into 4 even parts, okay? I know this little picture is hard to read, so I'm going to specifically tell you what each of those things mean, all right? Each part of the graph is a quarter of the data, so it represents 25%, each part that we're going to look at shortly. That does not change, does not matter if it's an even amount, okay? The percentages do not change, okay? So, when you're graphing a box and whisker, the plot has to go above or below the number line, not on it, just like you see pictured, okay? So some of the numbers that make up this box and whisker are the 5 that we see here, okay? That is called your 5-number summary, okay? The 5-number summary consists of the lower extreme, which is your minimum, which is right here. And I'm going to use this diagram to help us explain. The minimum is your lowest number, sometimes represented by a dot, sometimes it's not, okay? Then we have the first quartile, which is noted as Q1, okay? Quartile 1. There is 25% of the data. So this first line that you see is quartile 1. So the percentage between the minimum in quartile 1 is 25%. That will not change no matter of the length of that whisker, okay? The next piece, the second quartile, we don't call it the second quartile, we call it the median, okay, which is 25%. So actually, this instead of 25, sorry, should be 50, because from this line, quartile 1 and the median is 25% of the data. So from the median to the min, that includes half the data. Think of our normal curve. From the median to the tail, it was 50%, correct? This is the same thing. Then you have the third quartile, the median of the upper half. There is 25% of the data above quartile 3. So when you look at quartile 3, you have the median to quartile 3. Can anyone guess what that percentage would be? The median to quartile 3. What would it be? 25. The median to the last number would be 50. Okay? So, the last number, or 5-number summary, is the upper extreme, which is called the maximum, as we know. Okay. The maximum is this last number, and from quartile 3 to the max is 25%. Okay, so it's split up in 4 even parts. Okay. There's one piece that represents the spread, which is the middle 50%. It's the interquartile range, the IQR. Okay. To find that, we take quartile 3 minus quartile 1. That explains the spread of the middle 50%, where the majority of the data will lie. Okay, does that make sense? Okay. Typically, we use the median and the interquartile range if there's a ton of outliers. Okay. If there's outliers, we use the median, which is the center, and the middle 50% gives us a good idea of how spread out the data is. Okay. Those percentages, 25, 25, 25, 25, that does not change. Doesn't matter if the length of the whiskers or the box, whatever it is, that does not change. Okay. So we're going to look for this in our calculator. We're going to do it the same way as we have been doing. Okay. Go to Stat, Edit, and enter in number 3's data, which is the number of calories in each sandwich. So clear, enter. So once you have the data in, Stat, Calc, 1var statistics. Okay. So they give you your mean, which is not shown on a box and whisker, but I want you to take note of that, is 371.7. Okay. Then if you scroll down, here is your 5-number summary. It's given to you in the calculator. Okay. So the minimum is 270, quartile 1 is 315, median is 340, quartile 3 is 430, and then 580. So you have 270, 315, lower quartile is always referring to quartile 1, 340, 430 is quartile 3, and then 580 is the maximum. So once you have your 5-number summary, okay, you create your graph. Now, your scale might look different than mine, okay? It's not giving you an option. However, I do not want to see those 5 numbers as your 5 tick marks here. That doesn't work. That's not how we graph, okay? So what I started my scale as, I started with 250, looking at the range 270 to 580. And again, mine's going to be different than yours. Every other tick mark, I went up by 50. Oops. Okay. So here is my line graph. Okay. I'm going to start with my minimum, which is 270. Okay. Then my lower quartile, quartile 1, is 315. The median is 340. Quartile 3 is 430. And the max is 580. Okay. So this is a rough, and again, approximation. This is what it looks like. Now, looking at this, what would you describe the shape as? Yep. The shape in terms of symmetrical, skewed right or skewed left. Okay. How many of you agree with Brian. Skewed right? Okay. Now, if it's skewed right, what's the deal with mean and median? Yeah, Phoebe. The mean is greater than the median. Well, let's prove that if it's skewed right. So here's our calculator. Our median was 340. If I scroll up, what's my mean? 370. So that proves that Brian is correct, that this graph is skewed right. Now, how we look at a box and whisker, if it's skewed left or right, we look from the median. The median is our benchmark. That's where we start. So if I put my hand over the median, obviously this side looks longer and the whisker is like your tail. That's where it's going out to. Okay, does that make sense? So if you're not sure, because there's some that might look skewed right or left, but it's actually symmetrical, go to your data, your mean and your median. Okay? Try example 4. Okay? Okay, try example 4. Through this one. Okay? What was the minimum? Brian? 63. What was the quartile 1? 71. Excellent. The median? 74. Upper quartile? Quartile 3. Yep. 79. And then the max? 84. So if you got this 5-number summary, you are correct. Okay, obviously your scale might look a little bit different, but if you're looking at your diagram, okay, your picture right there, your graph, what would we say? Is it symmetric, skewed right, or skewed left? Abigail? Symmetric, why? Good. The mean and the median are the same, okay? They were 74. So it might look like it's a little skewed here and there depending on your graph, but when you go back to the data, it's the same, okay? Does that make sense? Yeah, interesting. You can, but not just writing, okay, this is 63, this is 71, this is 74, that sort of thing, okay? All right. And the last thing for today, okay, is interpreting these things, okay? That's the big idea. That's why we go through these visual representations, is can you use the graphs to interpret, okay? Can you use the graphs to interpret? So you have below is a double box and whisker plot representing Carl and Angela's sales in thousands, okay, during the month of March. So some of these, again, are approximations. So you will have these like squiggly little equal signs for approximations. And in the question, it's saying approximate. So what is the approximate median of Angela's sales? If you have to draw a line or use your pencil, try to figure it out. What is the approximate median? What do we think? Yeah, Grace? 28. Sure. Perfect. 28,000. Here's the median. Good. What is the approximate maximum? Sam? 63,000. Good. Okay. Which salesperson has the smaller median? Laurel? Angela. Excellent. Okay. Now it comes to the true false. 25% of Carl's sales are between approximately 15,000 and 32,000. What do we think? True or false? Yeah. True. Excellent. Okay. Because 15,000 is roughly here. Okay. And 32,000 is our median. So it's approximation, which is roughly in that ballpark. From quartile 1 to the median is 25%. Okay. How about true or false? 75% of Angela sales were between approximately 18,000 and 58. Sam? True as well. Because 18,000 was quartile 1, okay? And 58,000 was the max. So all of that is 75% of the data, okay? Does that make sense? Okay. I will have your homework on the board for the remaining time, and we will continue with this on Wednesday, okay? I'm going to have you fill in these scores here, okay, test scores, because it is kind of hard to see. We are going to interpret. You're going to do these, okay, as part of your homework, 1 through 9, okay? This is 38, 72, 88, 96, and 102. Okay, that's the 5-number summary. It's a little shifted and hard to see. So, part 1 of your homework is 1 through 5. Okay, then you turn to the next page. Oops. 6 through 9. 0, 20, 48, 60, and 190. Okay, so part 1 of your homework is interpreting 1 through 9. This should take no time at all, these 9 questions, okay? Then your homework, this is on Google Classroom as well, okay, is in the green packet. This is in the green packet. All right, and I will add the notes, those 1 through 9 questions to Google Classroom as well, all right?